So, hello, good afternoon, everyone. Welcome to our this year's digital award ceremony for the Building Sense Now Global Award 2021. My name is Christine Lemaitre. I'm the CEO of the DGNB, the German Sustainable Building Council, and I'm one of the initiators of the Building Sense Now initiative. The Building Sense Now initiative aims to activate especially architects and engineers around the world to foster climate and cultural sensitive design, to make sure that we actively make our contribution to limit the climate change or the climate crisis we're already in, and to really foster this local understanding of buildings, this good architecture with low-tech design, with the right materials. And during that initiative, which I would like to all invite you to join, you can find more infos on our website. We can share over the chat later. The idea is that we basically share knowledge. We're running right now a masterclass in collaboration with Miserio, the aid organization. We're having this global award for the second time, and we're very happy and very honored to have selected I think a great person to bring the message across. 2 years ago, we awarded the award the first time, and the recipient was Anna Heringer, or is Anna Heringer, the architect from Austria, who's very engaged in building with rammed earth all over the world, which has done a great project in Germany, but as well in Bangladesh. She's at the moment working on a project in Ghana in Africa. So really a true believer and a great ambassador for our cause. And so we have, before Corona, we had workshops, and we hope we can pick that up again. So I would like to already invite you to join our initiative. What we're going to do today is first, I will welcome Ed Mazaria, the CEO of Architecture 2030. He will give us a little intro about the urgency and the responsibility of architects and engineers to do their part in order to achieve the Paris Agreement goals. Afterwards, Bruno Sauer, the CEO of the Green Building Council España, will introduce our winner, and then the winner will give her presentation. I can already maybe share that that's a woman. But before we start with that, I'd like to give the floor to Ed for his presentation about the relevance and I guess his activities on pushing or forcing, like I said earlier, whatever it takes to make the architects move and really become advocates for this climate and cultural sensitive design. So Ed, the floor is yours.
I'm unmuted now. Thank you very much. And let's get started. Let me share my screen here. Okay, so the COP is going on now, obviously in Glasgow, and the point of the COP is to keep 1.5 degrees C alive, so that we don't, essentially have a catastrophic situation in this world. So there's an old saying in the United States: if you don't know where you're going, you'll end up someplace else, and we don't want to end up someplace else. So where are we going, and what do we have to do? What do we need to do to get there? So this is the latest Ipcc report, and this is the 1.5, and what the report tells us is that to have a good probability of meeting the 1.5 at staying at that planetary warming temperature, our carbon budget is between 300 and 400 gigatons to have a good probability of staying at that temperature. So that's our carbon budget, and that's a good probability. So what does that mean? Well, roughly globally, we emit about 40 gigatons of CO2 a year. We hear everybody talking about they're going to phase out by 2050. If we draw a straight line down from there, we'll do fairly well this year, but this next year emissions is supposed to come back up. That's 600 gigatons. That's over the 300 to 400 gigatons, and that's less than a 50% chance of staying at the 1.5. So what do we need to do? Well, we hear the scientific community telling us that we need a 50% reduction by the year 2030. And if we follow that line down, if we actually do that, and then we follow that line down, we will phase out CO2 emissions by the year 2040. That's 400 gigatons. That gives us a good probability of meeting the 1.5. And for the building sector and the built environment, we can do better than that. We'd like to see a 65% reduction by 2030 and then zero out all CO2 emissions by the year 2040. This is the way we normally see how emissions are divided up. Building operations, 27%, then you have industry, transportation. But what's new is that we now know that building construction and materials is responsible for another 10%, and then infrastructure, all the infrastructure, the site work and the streets and roads and bridges, all that, when we look at the built environment, is another 10%. So the built environment is responsible for close to 50% of all CO2 greenhouse gas emissions. So we have a huge role to play. So how did we go from this, which was late 1800s, pre-industrial times, through the Industrial Revolution to today? How did cities change, and how did we get all these modern skyscrapers, all glass buildings? Well, the first modern building, considered the first modern building, is the Bauhaus in Germany. That was built in 1925. And here you can see structure moves inside the building, columns and beams, rather than masonry walls in very short spans. So you could open up the floor plan. You could hang now the exterior wall. It didn't have to be masonry, and get lots of glass and open up buildings. Considered the first modern building. So what was going on in 1925? Well, things were pretty primitive. We didn't even have TV then. We had the first Model T truck. We couldn't make transatlantic calls until 1927 was the first one. So things were pretty primitive back when we had the first modern building. In 1928, the architects, the leading architects and planners and designers in the world got together and held the first International Congress of Modern Architecture. And they did that to lay out new guiding principles, because at that time, cities were really polluted. We were burning coal, housing was in with industry, and people were dying at a very early age. And so they laid out these beautiful modern principles: function-based zones, get the housing out of the industrial areas into high-rise housing blocks, into parks, solar exposure. Le Corbusier laid out the tenets of modern architecture: column wall separation, free the design of the facade, open floor plans, lots of glass. So that started in 1928, essentially a utopian movement. Came to the United States in 1932. We called it the international style because we can import it and place these buildings anywhere because energy was cheap and we could climate control any building. By 39, you see the beautiful Johnson Wax building, big open floor space. By 49, you had the glass house by Philip Johnson, single glass house in a freezing climate, a cold climate in New Canaan, Connecticut. We could overcome any exterior environment with fossil fuels and inexpensive energy. And by 52, you had the beautiful single glass lever house, and we had high-rise buildings. By 56, we had entire cities based on the modern principles. So how long did that take? From the Bauhaus to the Lever House took 27 years. And we did all that with these tools. These were pretty primitive tools: T-square, triangle. We had to dip a pen into an inkwell. We didn't even get the first ink pen till 1960, and the first laptop till 1991. So we changed the world in 27 years with primitive tools. It took years to do a set of construction documents to get something built. We now have 20 years to meet the 1.5 degrees C target, and we need very, very quick reductions between now and 2030. So at COP26, we're asking everyone and all countries to commit to a 50 to 65% reduction by 2030, which will put us on track for zero by 2040. And this has been now signed and pledges made by all the major architecture, planning, and landscape architecture and engineering organizations in the world, representing over 1 million design professionals and 60 of the major international largest firms in the world that are responsible for over 300 billion in annual construction, also calling for the 50 to 65% and pledging to help countries meet these targets. So what are the planning and guiding principles that we need to set out to do this? To design all new buildings now, developments and major renovations, zero carbon, building operations, efficient buildings, electrify them and bring in renewables for the electrification. Use low embodied carbon and carbon sequestering bio-based materials and landscapes, and then densify, repurpose, reuse, or renovate existing buildings, neighborhoods. Rather than tear them down, the greenest building is the one we save and renovate because we don't have to redo all that structure. Solar is now the cheapest electricity in history. We have the tools to do it. We have incredible tools now. And all the principles are laid out in the 2030 palette. You can get it at 2030palette.org, everything from regions, cities, towns, districts, what to do. These are all the recommendations for how to design zero carbon buildings. And how are we doing? So in the United States, something very interesting happened in 2005. Floor area increased. It's been increasing since the Industrial Revolution. Energy consumption and emissions always increase when you keep building and building floor area, but something happened in 2005. All of a sudden, energy consumption in the entire US building sector did not increase. It actually went down 5.2%. And look at the drop in emissions, went down 30% between 2005 and 2020. This decoupling of emissions from floor area, even though we built over 50 billion square feet, is unprecedented in US history. So it shows we can reduce emissions and also build. And so what we're projecting is right now we're at a 30% reduction. If we make good on a zero grid by 2035, which our administration wants to do, we should be at 72% below 2005 levels by 2030 and easily phase out emissions by 2040. So how are we doing globally? Well, worldwide, we're building. We went up 22% in 2010, huge amount of building worldwide, and we're going to keep on building. Those are the projections, but we have to build right. So what's happening with energy use? Well, energy use didn't go up as much. It's really interesting. We're starting to see a little decoupling. It flattened out in 2018, and because of COVID, it went down slightly, 1% in 2019 to 2020. So we're starting to see that, but look what's happened to CO2 emissions. This past year in 2020, it just dropped almost off the map. It's amazing it went down so much. And that happened because of renewables. And we're starting to see now that same decoupling that happened in the US over the past 15 years, we're beginning to see that globally. And that's the good news. And the reason we had that drop this past year was in 2020, renewable power was the only energy source for which demand increased while consumption of all other fuels declined. That was the International Energy Agency. So can we keep 1.5 degrees C alive? If we do our part in the building sector and the built environment, we definitely will keep the 1.5 degrees C alive. Thank you very much.
Thank you, Ed, very much. I always love to listen to that, and I like the positive note, and especially the comparison with the tools. I mean, when you show that, it is really insane what we were doing in 27 years. And now, like you said, at the COP, we have now the big festival of pledges again. You know, everyone is pledging to do something eventually. So I think the key part is it's possible. We have the tools, but we have to get going. And I think this is exactly where the architects, you know, and engineers play a very crucial role. They have to fight for that with their clients, and they have to make these connections. So thank you very much for giving that intro and making the time. I know you're very busy, but I already have some ideas, so I will reach out to you after this webinar. And now I'd like to ask Bruno Sauer to join us on that virtual stage. There he is, live from Valencia. And Bruno and maybe I and Ed, maybe the three of us can announce this year's winner, and then Bruno will talk or explain a little bit about her. I was very happy that she decided to apply for our award, especially because Bruno and I, we have been before the pandemic. I mean, there's now the time before the pandemic and during the pandemic. Before, we were in India to do a Building Sense Now workshop, and we did it in a very special place in Auroville. I don't know from the audience who has been there. It is a very special place. I don't know, Ed, why you didn't join us, but we have to go there again. It's mandatory. It's a very, very hot location. I think it's like the hottest location in India, and we were spending 2 days in a building without air conditioning, and it was possible. It was a low-tech building. It's a community, Auroville, where I think the quality of the building and the understanding on how can we build in such a climate zone is a big part. And our winner has been working there. I think she will maybe show us something later as well. But so I was very happy she applied, and maybe Bruno, you have the honor.
You can go ahead, Christine. I know.
Yeah, I can go ahead. So I will virtually show for everyone. So this year's winner, unfortunately, we don't have a, how do you call that, with the drums? Ed, how do you call that in English?
A drum roll, yeah.
Architect from India, but she has an office as well now in Germany. So Bruno, maybe you introduce her a little bit more, and then we will give the floor to her. And Anna Hamu, you can already join us virtually if you want. Bruno.
Well, thank you, Christine. It's a fact, it's an honor to introduce our second award winner, once again a lady, which is becoming very interesting, having an award which are dominated by female architects. I like that. Well, when I went through the curriculum of Anupama, well, I will need half an hour more or less to read everything, and that's a little bit too long. But there are very interesting elements to read in her curriculum. First of all, she is a person who has been traveling around the whole world, which is also shown in the 5 languages that she speaks, which is on itself already a characteristic of someone who is looking to diversity, to community building, to being open-minded, not to conform yourself with what you already have, always rethinking what you experience to do it better next day. Someone who is really active in looking for new, or pushing the borders always to new limits. She has been member of, I think, 15 or 20 juries on the international level, many exhibitions, about 20-25. 14 awards from today on, there's the 15th. She had been in more than 200 conferences, doing projects, or her own projects, more than 120-25. And she's reaching the 200 publications and conference papers, which is amazing for someone who has been working for more than 30 years as a professional architect. But beside all these numbers, I think the most interesting thing to understand or to see in her architecture is what she really designed. And when you go through her projects, and it's true that in Auroville we could take a small touch of what that means, this kind of architecture. It's an architecture which is really creating a dialogue with the environment, with the surroundings, which is an architecture, the result of taking time to design correctly. To design on a human-based scale, putting the human being in the center of what's the space. There are no formal standards. Maybe the only standard that you can find is the spatial quality, the use of honest materials, the place of where do you put the user into your architecture. It is this kind of architecture where you reach the building and you feel more or less immediately home. It is really something where light and natural ventilation is it's a common characteristic. Low impact architecture, completely fitting in our actual debate on decarbonization. on a certain moment when I was exploring the project, I thought, yeah, the element of time is so important in this whole way of thinking, that you can consider it somewhat as the yeast into the kitchen world, where that product in this time, you can speak about time, is something which makes all the rest bigger and better. When you take your time and you don't force the whole process, everything starts fitting into each other, and that makes it really, really high quality. I think, and to close, to summarize, and then pass the mic to Anupama Kundo to give us a presentation on her works. I think she's a living practice of building sense. So that's really, we are feeling it's an honor and a pleasure to have you as a new ambassador and a new award winner of what is our Building Sense Now award. And it's a pity, like Christine said before, that we can't meet in person to give you the award and to speak and to talk and have a drink. But for sure, we will look for a moment and a place in the near future so that we can do that. Thank you very much for accepting and being our prize winner. And I give you now all the time to share with the audience your experience and your project that you would like to show.
So good evening, everyone, and of course other time zones. So greetings. Thank you so much. It's a great honor to receive this recognition from you. And yes, I'm overwhelmed. It has come as at short notice. And I'm going to share I'm going to share just one project with you. But before I do that, I would like to first of all tell you that I discovered that the word building, and because the award is called Building Sense Now, for me the word building already is the process, it's the verb, not only the final product. And I realized that it's when you look at building as a process and not only the product, then you can change many more things in a holistic way than if you were to only look at it as a product which is static and just as if an assembly of materials. So I mean, we know as architects that buildings have very much to do with the non-material. It's the void in which the humans feel well and inhabit. But of course, it is the materiality particular to our times that has caused enormous imbalances, whether it's environmental, social, or economic. And in that sense, we have to, exactly in that sense, build sense, you know, through building architecture. And I think for me, it has also been a pursuit of building knowledge and building community, because I think that we are at crossroads, and what we know is all our past knowledge and past references are going to fall short for the future, because we don't know about what the future brings. But what we do know is that the future is advancing at a very high speed in an exponential rate. So not only building of knowledge of building upon past knowledge will suffice, but we need to count on human imagination, the human capacity to experiment, and adaptability, humans able to adapt and work together in a collective. And I think these qualities and human capacities will, along with human optimism, be able to steer our way forward and create new technologies and ingenuity to put materials together in unprecedented ways. So I think alongside the pursuit of new materials, maybe it's more important to consider materials, that the non-material aspects of human resources and human resourcefulness, that's where we can focus. We can use our time, we can use our muscles, our intelligence, our care, all these human principles, how we will be using, being more humane, we will be able to use our materials in a new way, because materials by themselves, it's not the materials that are sustainable or not, it's how humans move them from one place to another place and apply them in in architecture, where architecture becomes a permanent capture of some of the materials, including urban waste. So in this sense, I think experimentation is very important, and we don't have time to repeat our old habits. So I think I would like to share with you the project that caught your eye, which was a voluntary art homes for homeless children. I would like to try sharing my screen. How do I do that? Actually, I forgot to test this with you before. Can someone advise me? Okay, show my screen. Okay.
Yeah, so we maybe turn our cameras off, so the floor is yours.
Thank you. So is the whole screen seen now?
Yes, maybe you switch into presentation mode.
Can you guide me to find that? Because
no, in the program now, I think you have to do that.
In the screen here?
On your computer,
right.
Yeah.
Okay. So I'm going to try doing this.
Yeah.
Okay, sorry, I'm going to scroll back. That looks embarrassing, but okay. Can you see my slide?
Yes, yeah, we see it.
All right. So I'm calling it Building with Fire. This was the topic of my PhD as well. And I'm going to walk you through a very pioneering kind of earth construction method. And that's why I've called it Building with Fire, because the technology we used for voluntary at homes for homeless children in Pondicherry, close to Auroville, this was a method to build large-scale mud houses and cook them, bake them into ceramic in situ. So instead of taking bricks which are burnt in factories, clay gets burnt in brick ovens and gets used as bricks combined with cement in masonry. Compared to that, in this technology, we build houses with clay on the spot. We use clay mortar, and then we build a whole earth structure, and then we bake the whole thing in situ, and the whole house turns into ceramic. Now I'm going to explain a little bit, because it looks very vernacular and homely and belonging to the place, but actually it's a very radical new technology. And it's an example of how there is so much research to be still done, so much more to be found out, even with materials which we have lived throughout thousands of years. We have built with earth for thousands of years, and we've built with bricks for 3,800 years. And yet this is a new technology that was pioneered by Ray Meeker, a Californian ceramist who lives in Pondicherry. And I will just walk you through what this involves. So typically, now let me see how to share my screen. Just give me a moment. I don't know why it's not moving. I'm not able to move my screen. I'm sorry.
You should on your computer. Can you not, if you just maybe click on the, yeah, now it does.
It moved, right?
Yeah, now it moved.
So typical brick kilns in olden days, like pre-industrial bricks, were fired in kilns that were made out of the stack of bricks themselves. So all over Africa, India, you'll find everywhere where you didn't, like before the Hoffman kiln and other type of kilns were created to make bricks industrially, this is how bricks used to be made. It's just a pile of bricks, and the bricks on the inside cook more and the bricks on the outside are colder, but they have areas for the heat to travel, and wood is fed inside each of the openings, and then a whole brick kiln, which is the stack itself, it all gets cooked, and then the outer bricks, which are not so well cooked, gets typically used in areas where you need less waterproofing, or they are fired in again in the next round. So in India, many areas like Pondicherry have a very high rainfall, and it's difficult to build earth construction because earth is vulnerable to water. So this is a technology that can allow the use of ceramic bricks, like bricks to be used, same material as waterproof, water resistant as bricks, but not requiring any cement, because the whole structure becomes like a brick. Now, why am I starting with the kiln? Is because already there is local knowledge to build bricks in an area where, if it is not industrial, what happens is after the monsoon, always the clay collects in specific low-lying lands, and that kind of clay is usually ideal for not rammed earth or other forms of earth construction, but that kind of earth is usually best suited for making burnt bricks. So this is a very typical landscape you see of a local economy of brick making, which is a non-industrial method of making bricks according to how much clay there is, and it is done every season. And the same people do other things during the season. They are probably doing agriculture, and they grow the fuel for baking the bricks and so on. So this technology builds upon an existing local economy, and the idea is to strengthen that local economy. So that is one reason to base this kind of technology. The second thing is that normally when you bake bricks in the industrial oven, you need about 980 degrees centigrade. So the bricks are the kiln absorbs about 40% of the heat you generate. So every time you do a firing, straight away you lose 40% of the energy into the wall of the kiln themselves in the industrial kilns. Now, this is a technology where the house is a kiln and you cook other bricks inside it, and with the heat you would have otherwise wasted, we trap that heat and you direct it to cook the wall of the kiln. Okay, so inside the house is like an oven, and you fill other ceramic products inside, and then the energy that would have been otherwise lost is directed, so with the cost of a mud house to get a brick house for the outer walls. So I want to also make the mention here that if we want to really be sustainable in terms of the embodied energy, not only the running energy of buildings, the embodied energy, then we have to not start only by choosing materials from building catalogs, because the first step is to source material, because not only is it involving transportation, the more local you want to build, the more you have to understand the intricacies of how the sourcing of a material affects a territory, first of all. So in this kind of territory where clay exists, people are growing this kind of wood through reforestation. You know, they cut the branches of wood that is grown for building scaffolding, and then the thin branches are routinely taken from their own plantations to fire this type of temporary kilns. Now, I call it temporary because when the kiln is finished firing the bricks, typically, then everything is taken down, the bricks are dismantled, the bricks are sold, and the landscape is like blank again. So this is the old way of doing things, and we are building upon that knowledge. So this is Ray Meeker, who being a ceramic artist, he had a background in studying architecture in California, and he pursued the work of Nader Khalili, an Iranian architect who had stumbled upon the fact in Iran, after a fire, he noticed that mud structures were cooked in situ, but not fully cooked, partly cooked, and he got the idea. He wrote a book, Racing Alone, where he envisioned this type of an idea. But it's Ray Meeker who systematically solved all the obstacles in baking a large-scale house in situ. Now, normally, Ray Meeker was very energy conscious, and he felt that if you don't significantly reduce the energy required to cook bricks, then it is no point doing this, because a lot of building rating systems say that brick is very high energy consuming. On the other hand, we also know the brick is so durable throughout. The earliest brick is still strong. So there are many reasons to consider that if the fuel is a local one, and that there are, and if it is reduced significantly through wastage, then brick could continue to exist in a new form in a very efficient way. And for example, in this case, you don't even need cement, and you need not bring any other material from outside. Also, the roof is made with clay. So everything in this building is made with clay, but it's cooked in situ. And the limitation of this technology is because you want to avoid the use of any other complex material for roofs, like like a concrete structure or a wood or whatever, because in many places, like in India, where you have high population, you won't have enough, you cannot use wood so easily in these humid places. So the architecture has to also support itself. So we have to build vaults and domes, for instance. So the idea of the orphan, not orphanage, sorry, it is for homeless children with foster parents, this project. So there's this NGO who conceived of this project called Voluntary Art, and we have started working with these circles because the structurally stable form for this kind of technology is best used in this kind of, the strongest is to use circles. And because of the law of gravity, it's good to use catenary shaped vaults and domes. I realized that if you want to make the structure very thin, instead of the previous experiments that Ray Meeker made, where the walls are thicker, it becomes very difficult for the heat to go through the entire wall to cook everything properly. So I thought that this is a place for children. If we can make it very thin shells, it'll cook through. And therefore, I have, instead of having walls and buttresses and leaning walls, I thought it's easy to make it not so massive and use it like an eggshell form directly. It also gives a very secure space to children. So there are 4 clusters for children and foster parents, each cluster, and then there are bathrooms and play areas in common. So what we did is, in such a technology, you have to anyway do, first build a mud house from bricks, locally made bricks. And you can see there are many students here from different schools who had joined us in this workshop to build this technology. But if you observe the way the plinth is, you have one layer of baked bricks, and there are little holes through which oxygen can enter during the cooking process. And then there are bigger holes on top from where the firewood can be placed, just enough firewood to start the fire. Now, in Ray Meeker's past buildings, most structures were built with firewood, just like the local people make their bricks, in the same technology. In this case, what we did is we used even less embodied energy, because we took coal dust from factories where there is a coal powder residue, and it has some calorific value. So we mix 5% of coal powder into the clay, and we made bricks out of that. So when we start the fire, we need very little wood to start the fire, and after that the brick burns from the own fuel by contact. And also the form work for the windows, etc., we have used anything from the waste materials like old bicycle wheels and so on, or we have used pots or whatever we had to make these circular openings for windows. So we tried to buy nearly nothing. So it's most of the money goes into labor. And if there is in the Western economy, everybody thinks that the time is money, so we tend to save human resources, human time, because it's costly, and we land up spending much more materials. In my opinion, I feel much better to spend the money on people and not on materials, because then there is an enrichment of not only individual people who work, craft people, but also of the local economy. And the more we use human resources and human resourcefulness, the less we use natural resources, because human resources are infinite and natural resources are finite. So if you use your intelligence more, maybe you work twice the time or 3 times the work, but you save a lot of materials. And I think this is my formula for the future also. So this is how the earth construction is going on here, as you see, with a simple frame that you rotate and build everything with clay and clay mortar. And then afterwards, when the whole thing is over, the construction is over, it has to be protected that the structure doesn't become wet, because it's only clay. So you have to make sure that it doesn't rain, and you have to pack it in case it does. So that is a very, very important stage of and boring part of the work, but it has to be planned because the structure is very vulnerable to water. Once the building is ready, now the kiln, the oven is ready. The house is the oven, right? So first the house has to function as an oven. So inside this house, we have started stacking the bricks in such a way that you will see in the lowest layer, there is oxygen coming in like a grilling platform on which the bricks are stacked. So from the fire boxes, which are open on the wall, there is a little bit places to start the fire with wood. And then all the above layers are just brick. There is a little bit of coal dust in the bottom layer just to start the fire so that the fire doesn't go off. And then afterwards, all the rest of the bricks will fire from the own embodied coal content inside it, only 5% of that powder. So then the structure is sealed with mortar, I mean just mud plaster, everything is closed, and then the fire is lit. And what happens is that it cooks for 3 or 4 days, but till the whole brick is cooked. In the former experiments of Rainmaker, the brick wall was not getting fully cooked because it's very difficult for the heat to penetrate on the outer wall up to 980 degrees. Maybe the outer wall is 400 or 500. So he found out and made a breakthrough by applying a combustible plaster layer of rice husk and some fuel, some kind of either cow dung or something which has a little bit of a bio material that can catch fire. What happens is by the time the outer wall reaches 400 or 500 degree temperature, the outer insulation layer catches fire. So in the last stage, it gives a lot more heat and the wall cooks through. This was the way Rainmaker actually solved the cooking of large clay structures to make the heat penetrate throughout. So this is how that looks, and openings through which you can see the brick glowing when it's being cooked. So then you can see here the structure is almost cooked, and then it's cooling down for 3 days. You can see when you touch it and it works, and then you open the windows and you start taking the bricks. So you see inside we have got all the bricks that are already cooked perfectly, and that you can sell, or you can finish other parts of the house. So the house, what was interesting for me in my PhD is that this is a method through which you can see the house not as a consumer of building material, but as a producer of materials, local producer of local economy and of building materials. So the house becomes a producer rather than a consumer of building materials, and that changes the socio-economic impact of, like taking the fire to the building site as opposed to taking all the clay to a factory, manufacturing, and then bringing large quantities to transport in different places. And this is a technique that brick makers who are doing small scale can easily do and provide themselves with waterproof houses. Of course, what is very important to know is in this case, we have done only bricks, and we can design bricks of our own sizes. But Rainmaker has done in other experiments, you can put whatever you want, wash basins, there are all ceramic things you can put in. You can make toilet pans, tiles, glazed tiles, furniture, water spouts, gargoyles, all kinds of things in ceramic still exist. So all of that can be produced at the same time. And then of course here this is a research project, so we were studying how the fire moved, where did the bricks cook well, where did it cook not so well. And then finally we had the project like that, the end, and we made the toilet block, which is in the foreground, made out of waste bottles, and we completed the surface, because glass and is the same vitrified product like clay. So it's like sand which gets converted with heat, so we use the same technique. And also on the top of the domes, to allow light and ventilation, we have used broken chai cups, etc., to finish this masonry. It's an idea to be able to also use circular materiality strategies, like we recycled the bicycle wheels. Similarly, there are many other elements. We try to not buy any materials, take everything either from the local soil or from urban waste. And even some other, because it's a project with very little resources. So here you see we have used terracotta pots and a chicken mesh for the connecting domes to be able to make some elements with very little steel, the mesh there, which always farmers have access to. And so there was a lot of research here, and this kind of terracotta pots have been kept as storage for the children to keep their special toys and like little cubby spaces for themselves, for individual storage, for according to the height of the children. So you can see how those interiors are. It's a very, very humble project. And the final waterproofing is also done by using broken tiles, which are glazed ceramic. So basically all the materials we are using mostly have gone through fire to stabilize clay, to make clay waterproof, because this is a very high rainfall area. You can see how it is being used. But more than the fact that this is a mainstream technology, what I wanted to do through this project is that beside a PhD that I have done in the same about the same topic, building with fire, I want to stress the importance to create space and time for experimentation. And I want to really thank you all for noticing that even though these are not photogenic, typical architecture projects, it is something that that has a very rich process, a lot of scientific thinking about material sciences, about social aspects involving the people in their construction, because a project which has no resources to build with, you realize that if you go to places where people don't have any resources or surplus money to make architecture with, you realize that when you feel you have nothing, you still have something, because you have your life, you have your time, and there's always some material lying around you. So instead of focusing on shortage, you can focus on what is abundant. Is there soil abundantly? Is there something that humans did not yet find a way how to use? There's always something. So if you combine human skills, whatever is existing, with human ingenuity and human time and care to bring everybody a modest habitation, then I think with whatever you have around you, we can find solutions. And sometimes having a shortage of resources could even be a blessing, because we are forced to use our intelligence and our ingenuity, and then we become clever. Thank you very much.
Well, thank you very much. Very, very impressive. I really, from your application and from the internet, so we did some research, but hearing it with your words, it's a very impressive project. So thank you very much. And I think this is something we really need to get out there as a message. And I like your last statement about, maybe the shortage of resources is a good thing, because then we have to start to reinvent and think about other things.
Have you managed to take me out of screen share? I hope.
Yes.
Think. Is that okay? Okay, good.
Yeah. Yeah.
Thank you.
So I don't know if we have some questions from the audience. We have a few more minutes. I don't know, Ed, Bruno, from your side, any comments, excitement for our winner? I mean, unfortunately, it's digital, but we have to, you know, make it a little bit a celebration.
Just only huge.
Yeah, it reminds me of the old.
Go ahead, Ed.
Go ahead, Bruno.
No, you can go. Go ahead.
Oh yeah, no, it just it reminds me of the excitement in the old solar days back in the 70s when we had a big energy shortage, and all over the world we were, you know, exploring new ways to build that didn't require any fossil fuels and energy, and that's how the whole passive movement started. So everything was essentially passive back then. We kind of lost it a bit after in the 80s when the energy crisis subsided, and we kind of went back to the old ways of doing things. But it's resurging now. So you know, all the things we learned back then are coming back around, and it was so nice to see these projects. Anupama, it was really refreshing.
Thank you. I think one of the things that I would like to respond is, even though it looks, some of the things look like we are going back, it's interesting that there are so many open questions, even in what we had done in the past. And in that sense, if we pursue them, it could be quite futuristic. But I would like that the people who are creating rating systems should also maybe not only look at the quantity and the how many kilojoules goes into, you know, of energy, but it should also be seen what kind of qualitative choices for fuels that one makes, you know, whether we use things that are local or whether they are coal or whether they are, you know, coal dust, which, you know, there's so many layers. If you don't just go quantity wise, black and white, it would be really good to put some attention on the exact specifics, because every material comes from a specific spot, and that has already some other social and environmental impact and transportation.
I was really impressed by the turnaround that you gave on the concept of embodied carbon and embodied energy. Normally, we say that for making materials, we spend energy and then we link it with some carbon. Now, what you did, you put carbon into the material to save energy. I mean, that's a really funny way of working. Even it was just a 5%, but it's a very interesting way of using knowledge. Scientific knowledge to improve processes on a low scale, on a little scale, but on a family scale, more like community scale. But it can be very, very inspiring for many other people in many other projects. So thanks a lot for sharing this.
Thank you. I also am very curious to see more studies where we can compare how much of human energy and how much of machine energy and how much of fossil or other fuel energy combined in a project like this one even. But it would be great to do those more subtle studies behind the energy implications for the sake of local economy.
Yeah, and I think this is the message as well we have to get across. Now we have one question from the audience, and the question is basically, what can architects in Germany learn from these experience for projects like you made? I mean, you have a practice here in Germany. I don't know if you have some projects here, but what would you say? What is the knowledge we need to implement maybe here, or what can we learn?
See, I would like to share my personal feeling on this, not only as a practitioner now with an office in Berlin, but also as a professor in Potsdam, and also, you know, visiting some of the German schools often. I feel that there is something of the post-industrial age in which all the man-made codes and laws have been taken so fixed, you know, that they have created new habits where people don't trust even to imagine other scenarios. So I feel that there are man-made laws today governing what we can and cannot do. That has always been evolving. And then there are natural laws like gravity, like how the sun path flows, and the actual physicality of a context and the climate, whether it rains or whether it's dry, it's cold. So I feel that we should create a culture, and even in the developed countries all the more, we have to realize that the natural laws, it's good to surrender to the natural laws, and it's good to challenge the human man-made codes and laws, because not all the laws are serving us. Many times codes are made for an overly standardized situation everywhere, but the codes are made to ensure certain safeties, etc. But what has happened in a lot of the local culture is that these kind of habits of building everything without knowing the first principles, but directly looking at other buildings and catalogs, just repeating the way the building habits, because we are insecure about the first principles, that is very, very limiting. So I feel in Germany, what I try to do also in my own studio, I like to make sure that we understand the first principles and we take time to learn what we don't know, so that we don't blindly repeat. We should make a distinction between information and knowledge, which is an integrated thing, you know, where the intelligence will act, and architects will have the capacity to produce innovations which are relevant for the future, instead of using the man-made law as a kind of limiting device, you know, mechanism. I hope that answers the question.
I think, and it leads perfectly to the next question, which is, it's a very tricky one, and maybe from your experience, but maybe Bruno and as well Ed, even if it goes around Europe, but I think it's about maybe our a kind of global north culture. Why are we in Europe so stubborn to keep building the overwhelming complex way we do, instead of relearning from simplicity once again? I think this is the question, the $1 billion euro question. But maybe Anupama, from your experience, your line of work, how hard is it to convince clients or colleagues?
I think it's if it's hard or not, I think we should not be bothered about that. You know, what happened, what succeeded in my case is, it's true that in India it might be in some ways easier, but in many other ways it's more difficult, because we don't have resources to do experiments. We have nowhere to apply for grants, you know. There are many disadvantages, and this is not how most people build in India anyway. I come from Bombay with skyscrapers, you know. So it's not like my context only made it easier. What I would like to say is that I think in developed countries, because there has been mainstream industrialization, last 2 generations are the people who have always lived with ready-made, you know. So you go to buy a dress, it is S, M or L. Even it doesn't fit you, maybe the over standardization. So if it doesn't fit you, you think that something is wrong with your body, instead to think somebody over standardized, you know. So you get so used to just use a standard thing. So many of the beliefs, many of the limitation are in our own head also, actually, I feel. And I think that's what happens when you are raised in a country where it is mainstream industrialized. So you feel anything you do custom made is something very unique, but it's not actually true, you know, because the custom made architecture is a custom made profession, actually. Yes, today there are offices building, the large scale offices building all over the world, the same solution, the same tower in Frankfurt as in say Tokyo, you know, or in a different climates, Middle East, all the same. So this actual architecture profession is a custom made profession. So we should not, I think it's a myth. In the developed countries, there is an economy which makes it is a throwaway culture, where it is cheaper to throw away. So you feel that if I pay a human's time to do an individual custom made thinking, then we cannot afford it. But that's why we are doing much more work. I think a German in Germany, what I'm trying to do is work more with economists to figure out how the true footprint is calculated when you throw away something. And when you start actually counting the real economy and not the sponsored economy, then you will see that when people are more clever, it is actually cheaper, and custom made can be cheaper.
Okay, this is I think a good statement, but maybe to bring Bruno and Ed, who've been working in that field for so many years. Why are we so stubborn? Bruno, and then maybe, or Ed, who wants to go first? Ed.
Yeah, I'll say something. You know, I think you know, in architecture school and all the professional schools, we really have not been teaching all the natural environmental principles that should apply to architecture. You know, where's the sun? How does it move across the sky? How does it enter a building? How do we passively heat a building? And how do we cool a building? How do we ventilate a building? How do we daylight a building? All those things need to be taught in design studio. Right now in education, they're allocated to a seminar or you know, outside the studio. But every project should have to deal with that, so that by the time so that in a sense, almost every piece of architecture and building that we do is location based. It's really, you know, it's really local and responds to local conditions. And now we have to add another dimension to that, and that is to project what the impacts of climate change are going to be, so that we can, you know, incorporate those in building structures now. How high is, you know, flooding and sea level and temperature rise and all that? We're going to have to deal with all those issues in architecture. That has to start in studio, and every studio project has to really look at those issues. But so that by the time these kids get out, they're changing the culture of offices and dealing with this. We've been doing this for years, so we know how to do it. We just need to actually do it. That's all.
Yeah, Bruno, we need to do it. What is your take? You're on mute. Still after.
Ahora estoy. Well, it's true. Yeah, we have just to do it. The biggest problem for me is that a little bit what Anupama was saying, that since our industrialized society, we are trusting so much on standardizing everything that we are completely switched off our own intelligent or our way of thinking as an individual. We just trust on, as long as the society, government, or rule makers are not saying what we have to do, we are not doing it. So I think that's a general critic on society, that we lost our critical sense. We are very afraid of leaving our comfort zone, and the comfort zone is completely defined by regulations and standards. So as long as we can't break that mechanism, I think, or we have to wait for more regulations to solve the whole climate problem, or we have to start counting really on the individual responsibility and way of thinking and acting, and rethinking what you also said before, Anupama, that we have to start rethinking what we did, so that we can fasten up the whole transformation. So I think last week I was in a podcast on the radio, and they asked me, yeah, what could be a nice conclusion for society if you speak about climate change? And I said, yeah, as a grown up, as a parent of children, when you go to sleep in the evening and you're laying in bed, say, look what I did today. If my children are going to do the same, then we are solving the problem or not. And if the answer is no, just stand up tomorrow and do it different. Because I think that's the only way of showing to the next generation, or to children, or to other people, that we have to start being critical again of what we did, and not just trusting on upper level regulation institutes or standardization institutes that to give us a solution. So I think it's a clear message on intelligence and critical, responsible, and breaking a little bit the comfort zone, and then I think that we will reach it.
Yeah. So I think breaking the comfort zone is a is a very good closing word. Unfortunately, the time is up, but this is the start of a conversation. Anupama, we will continue to have that, and we will have an occasion to personally hand over the certificate and continue that discussion. So congratulations again. Thank you again for accepting and supporting the cause. And thank you to Ed and Bruno as well for taking the time, and everyone listening, and looking really forward to continue that discussion and to wake our friends from the architectural and engineering world up even more. I think this is very, very, very necessary. So thank you, everyone.
Thank you.
Thank you.
Thank you. Bye.
Take care.
Bye-bye.
Thanks,
Bye.
Ed.